Hello, what's going on? I'm Jun Chan. Welcome back to the stream. We are back doing pretty much the same thing, hey? We're doing some Purescript and we are working on a Comonad instance. So I think, where were we? Yeah, we were actually writing an arbitrary instance for graph, which is something that I haven't done yet. And let's see. So yeah, I was trying to make this work here. And let's see. What is the one that's failing here? This extend, extract. Right, we still have this extend extract that's failing and I'm not sure why. Yeah, so that's also something to fix. Let's see, I should have it somewhere, I suppose, in my... Oh yeah, and I haven't done my housekeeping. Okay. And we still have a... Yeah, we still have this failing test here. So those are two things we're doing. Arbitrary instance. Okay, let's start with the arbitrary instance. And we were trying this. And we were having this type error here that I couldn't figure out. Right. Okay. So we are using one-off, and one-off should be used with a non-empty array of gen A. And so we're hoping that any from non-empty, right, is going to transform a non-empty space array to a non-empty array, which is what one-off wants. It wants a non-empty array without spaces, so this converts it. Apparently our V is of the right type, it's of the gen A type. I believe. Can we do this? We might need to import the constructor. And if we do, then it's not the right type. Yeah, that's that's interesting. So let's go back to the documentation we were following. So in theory, we pass arbitrary here, which, well, okay, I'm not sure how the parentheses work here. Let's see if V has the right type, but it doesn't. V is a graph of T2, whereas if we say gen A, well, yeah, we actually, oh, I see. Well, leaf, no, leaf contains an A, which is like our vertex. You know, I'm not sure whether this is right or not. How could we find out? I mean, we could just follow the types, right? Arbitrary. I suppose if we do this, wouldn't that be? No. Do we want a vertex of, what do we want? We want some gen A. but we're inside this fixed point though. And so this G, we expect it to be a gen of graph A. Am I correct here? I think so. And that means that our one-off should be of graph A. So that means that somehow we'll stick a graph inside this vertex, but we don't really want to do that. Here, when we get this P, is it of type TA? I think it is. And so when we do the fmap, we are going under, we're using the functor instance. It's weird that this gives the same type error. And let's try and write the type for R. R should take what, a gen of graph A to a gen of graph A. Is that right? Maybe not. A gen of graph of graph? Oh, an array, right. An array of gen of graph A. Maybe so. But then this empty, we want to be, well, let's not put empty and see what happens. It type checks then. Huh. So we might need to make empty, well, type of gen of graph A. Is that even possible? That does not make a lot of sense, does it? We want a constant. How do we generate a constant? Okay, one off here. No, it's not here. It's in gen. Variant size, choose one off. And this stuff, shuffle. Uniform. Gen of graph A. We do get the gen. How do we modify? Oh, variant. Actually, we might want to vary this. And we would what make the seed? Whoopsie. values. We want a gen of graph A. And gen. So yeah, we could just construct, we could construct gen by creating this state, which is a state monad, all right? Which returns always empty. Let's try and do that. Gen is the type constructor, which we need to import. If I hope it's exported, it is not exported. Okay. So what's the smart constructor here? Can gen uses the generator state explicitly. F applied to S, returning the seed. Yes, okay. I think that saying stateful const empty might be what we need. And we need to import stateful. Yeah, that would be, we're not returning gen A here. Yeah. Okay, let's do a search. Okay. Test.quickcheck .gen in Purescript and constant values. Magic constant. Wow, the weather is crazy. Can we? I think there is something that where we could take the G and replace its payload by empty. It's something like that. Let's see. Could be dollar. FAB, FB. So FA. It's void left. Okay, so this. Yes. Good. And I suppose we could do it like this for symmetry. So does that build? We don't need stateful. Yeah, it does. And so can we try our commented out? So this one has, yeah, this one is tough, so we'll do it later. Let's try. Okay, so that's the context. Where is, didn't I have, yeah, this one. Simplifies arbitrary graphs. Spago test. And what are we missing here? Arbitrary for graph. For T1, right. So we need to say what type of graph it is, I think. So we say, make this a graph event. No? Oh, yeah. Maximum cost size exceeded. Right, so that's where we start to go back here and yeah. So the laziness didn't help us or didn't help us enough. We do have to use the size argument. So let's see. This takes size. Okay, yeah, I think I can see how this works. Maybe. I don't know about the fix though, but we'll see. So, GNG object. For them, extend object. Maybe this is what gets in the fixed point here. From a JSON and some string. You insert the string. I can't really spot the recursion here. There is differ. Yeah, we gotta remember that this is a different gen, which doesn't help. So let's see. Let's make that whole thing a function. Gen graph. And we'll say that it takes, well, as it's written, it takes a gen graph A and it returns a gen graph A. Why am I typing so badly? Yeah, probably because I was typing gen graph, just gen graph actually. Different A, right? Well, yeah, we can make it for all A, that's fine. No, we do need the arbitrary A, yeah. That's also fine. And oh, G was shadowed. Okay, yeah, that's fine. At this point, maybe I simply do this. V is vertex arbitrary, yeah. The type annotation was necessary, so let's maybe at least where would it matter? If I say this, is that going to be enough? Let's remove this. And yeah, I'm missing a parent. And no. Non-empty array, yes. Yes, that's fine. I see. Well, it just imported. I see. So this whole the type annotations are needed. So let's just call this gr and this gr. How about that? Okay. Now back to the resizing. So I think we could pass a. We're not exactly recursing here. We get past the gen graph. Okay, yes. So we should give I think gen size will take a or maybe resized. Which one? Sized. Depends on the yes, and resize modifies it by setting a new size parameter. So I think if I say it's sized, I think right. Is it that at each step it needs to be resized? Oh, there's a test resize here. Initial size 2. Yeah. Sized pure. Okay, yeah, that is not easy to understand. Yeah, at each step you do a gen resize. Two gen sized gen JSON prime that takes a size. Yes, so let's take a size. And then let's resize in that way. probably just size -1, no? Generally size. Oh, no. Yeah, no. Size -1. Blah. Oh. No, I think I'm still not clear about how to do this. Yeah, there's an otherwise. I should have an otherwise somewhere, depending on the size. Right. So indeed, if size is more than 1, then generally size blah blah blah. Otherwise, otherwise what? Just put a vertex in it. Yeah, I think V. And what does min5 means? Do we have min here? Oopsie. We do not. So it's doing resize with gen sized. Okay, so gen sized. And then you give it a size. Is that what's up? I don't know. Let's try. Yeah, I suppose we could import this as gen. Oh, so the where clause is in the wrong spot. Still. I didn't realize this. Okay, let's try this. Right. Now that this is here, we're talking about the same A. Yes, and then sized. Takes yeah, that seems fine. Oh, I see. So, right. So that's a different way to do it. Like my fix is in the wrong spot here. Because size doesn't take a size to gen A to gen A. It takes a size to gen A and it returns gen A. So the fix point is inside so I suppose here size was shadowed. Yes, okay. Oh, that compiles. I'm surprised, but seems like my equational reasoning was completely off the charts. But we still exceed the call size though, so back to the same problem. All right, I just had the insight of what min5 means. I think it means, actually is min here. It means something random, but, oh, minimum 5, right? So it's 5 and up. Yeah, stack overflows are not easy to solve in Purescript, or at least I haven't yet figured out a way or a good understanding of that. Okay. So is there a way we can not use that fixed point? How is this happening here? There's a resize and a choose. What is choose? Samples a range of numbers with uniform probability. That doesn't sound like that's what we have here. That's not a number. So it must be either this or this, an array or a gen.j object. Then it resizes, and then the gen.j object, or the gen.j array, for instance, is from array, and then it unfolds and gen.jsons again, which re-enters. So let's try that. Let's say that, how are we going to do that? So we don't fix point anymore. And we do we gen graph? I suppose we do. Well, we don't need to do this anymore if I'm, or what? So the thing is, like, we gen resize here. Hold on. No, still not good. I'm thinking that size is going to go in the monad. I might be right about that. Yes, it goes in the monad. So, meaning it's when I do resize, I'm actually updating the state monad, which is weird though, because when I do, so we need to find out what min means in this context here. Maybe it's in control monad gen. Oh yeah, I had this other example here, right? But it points to the same example, yeah. Not that useful. Okay, control monad gen. Min. What is min? Is it from bounded or something? It takes the minimum of 2 values. I see. So resize here is different. Resize is a function from size to size. That's one of the big differences with this resize, which takes just a new size. That's not great. That is not great. Because it means we can't use resize as a kind of a state modify function. We need to explicitly keep track of state, or at least, yeah, we might need to fetch it. Maybe we need to reach inside the underlying monad. So we need to do ungen and then modify or something. Oh, there is monad gen though. And that's from Purescript gen. And that has resize. Okay, so if we say that this is control monad gen, dot class, and then well, so resize becomes _1, and then here that becomes well, we can say min, and then, however, if we don't do the fixed point thingy, right, let's go back to here. Then we're supposed to just change this on, which in our case is sort of, I suppose I'm kind of trying to avoid making it, but okay, fine, I think I can't. So arbitrary is going to be gen graph, and gen graph is going to be whatever arbitrary is supposed to be. Gen graph graph is just gen of graph A, really. And that's going to be gen graph prime. Gen graph prime is going to take the int, but here it's going to be gen graph. And like so. And yeah, except R now doesn't take a parameter. And gen graph. Oh, for all A. But that's not really the problem, is it? Cycle and declaration. It shouldn't be a problem, should it? Gen graph prime. And I mean, we could also defer. That's, yeah, I'm not even sure that's really the problem here. Here we use gen JSON. What's going on? It's not this, right? This is not, shouldn't be a problem. Gen graph prime, gen graph prime, gen graph, gen graph, gen graph. Let's see if we don't use the instance. Yeah, that has nothing to do with the instance. Well, it's good to validate that. R. Array of gen of graph A. Gen of graph A. Here there's an M. It takes a lazy and lazy for JSON as well. Okay. Right, which is what allows to do this defer here, I suppose. Maybe I still need the fixed point, because I see that this lazy constraint might be serving the purpose of at least injecting some laziness in there. Which makes me wonder if that was a problem that I had with my fixed version. I don't know. Okay, yes, I suppose maybe I need no, I don't know what I need here. Do I need arbitrary A? Maybe I need arbitrary A here, but that's not the problem. The problem is the cycle. And it's not yeah, I don't know how to solve this. Okay, I'll take a tiny break. Okay, so what is this? Value of gen graph. Let's double check that we don't have other gen graphs described elsewhere here. We have this, which is the culprit. Cycle declaration. And clearly there's a cycle in this, but it's not a problem. Let's look at the cycle in declaration error message again. So hold on, could it be because of so maybe it is a way to detect that it's going to blow up the stack then, because we call gen graph directly without deferring. Well, that's pretty impressive if that's the case. So if that's the case, then then let's go back to where is that? Oh no, did I lose the? Oh, here it is, discourse. So do we need to do it differently? Do we need to do it with a lazy M? That doesn't seem right. Although I suppose I could, and then I could run lazy or something. That's okay, let's try. Comonads class. Let's go check out lazy and class lazy defer, and then fix from lazy will, given that L is lazy, will give the right result. So oh, there's fix from data lazy and fix from control lazy. Have I been using the right one when I was using fix? Well, I was actually, but I'm not sure I was using it properly, because in that case I should have been using defer or something. Okay, so let's say that this guy requires what does it require? Okay, I'm not sure. Lazy L given L to L. Fine, let's try fix. We say gen graph is now L to L. And so we pass it gr here. No, because we get, so okay, so we just do this and we just hope that they will work. Well, we need to pass G here and do gen graph A again and make this G and G, and then do R GR. And what's the deal here? What's the problem there? Unexpected token. RGR vertex gen graph A. Graph prime. I don't understand. What's going on? Oh, RG, okay. And well, it compiles, so that's a thing. And it builds, but I wanted to test. No, it doesn't. Does it? No, error. Oh, I need to import gen. Okay, Spago install gen. Oh yeah, it works. So, so then if we try to make the law apply, which is sort of what we wanted to do in the end here, do extend extract. If we try to do this for real, so to speak, meaning we, let's say, take the quick check, and then we try and say something like extend extract G equals G. Okay, with a pointed graph. So pointed graph. And we need the arbitrary instance for pointed graph. Not a problem. Not a problem. Pointed graph. Somewhere like here. And then pointed graph. We'll take gen graph, which will go from gen pointed graph to gen pointed graph. And then it will gen pointed graph and pointed graph. And then except that this time the G will, I hope, automatically be, that might be trouble. I might need another here, or maybe it will figure it out. We need to import a bunch of stuff. Like that. And like that, right? And Control Z. And that data non-empty as any. I think it's actually data non-empty array as any. No? Let's double check. No, it's data array non-empty. It should really be NEA, but yeah, let's make it NEA. And NEA. He says, well, oh, what's going on? What? Okay, yeah, maybe. And how's that? Ah, NEA here as well. Okay. And sure and sure. Okay. And this is data array non-empty and it's NEA. All right. Right. And then here, well, yeah, I'm going to have the trouble one way or another. It's going to be here or here. Yeah, that's right. No, not exactly, because this is p connect, p overlay, and oh, this is non-empty graphs, right? No, it's not. Right, so we don't have this case, and this is p vertex. Right, and then the problem shifts here, but here we should have. I suppose we could import the gen graph, which requires exporting it, which is fine. And then we import it as graph dot g dot. So fix gen graph. Yeah, that's tricky actually. That is more tricky than I thought, because because the gen that gets passed and whose size gets diminished at each pass is going to be different if we introduce a different gen graph. It's going to be a different state monad. Okay, well, that's what we'll try next time, because our time is up. We did do arbitrary instance for graph, but we need to do an arbitrary instance for pointed graph now. And that's what we'll try next time. Thanks a lot for watching, and I see you on Saturday, most probably. Bye-bye.